Well, welcome to our online students. Where did it go? There we are. .3 on page 355. If you're stumped on some of the problems on 6.1, it looks like you could scroll down to the bottom of this page for the online students who I've shared this with, this tablet, and you can look at some of the solutions to some problems on 6.1 that are a little tricky. Okay, in problem 1 through 10 on page 355, evaluate each expression. And the first expression says, what does that say? Can all of you read that? It tells you how to read it on page 351. When you look at that, you go, that's 15, that's 15 is all fenced in. Well, that's cute, but that's not the way you read it. 15 is behind bars. Oh, that's even better, but that's not the way you read it. So how do you read it? Look at page 351 and it'll tell you. How do you read it? Someone want to say how you read that? I thought some of you said you studied absolute value before.
So isn't it just the absolute value of 15?
The absolute value of 15 is 15. You go, well, that's dumb. Yeah, well, what about this one? The absolute value of negative 15 is what? 15. That's really dumb. No, it's absolute value. That's what it is. And page 351 and 352 tell you that. The absolute value, when I see this thing here and I say the absolute value of 15 is 15, the absolute value means the magnitude of the number without regard to direction. I don't care whether it's negative or positive. Now, I think the textbook says you ignore the sign. It's like you don't care whether it's to the left or to the right from 0. You just want to know the magnitude. You just want to know how far from 0 is it. So I could read this. The magnitude of 15 is 15. The magnitude of negative 15 is also 15. I don't care which direction I went from 0. I just want to know how far I went. That's what absolute value means. Does that help to think of it like that? I know the book says without regard to the sign, but what you're really thinking about is how big is this number, and I am not concerned about the direction. I just want to know the magnitude of the number. So the magnitude of 15 is 15. Now, number 5. Why did I do number 5? That's one of yours. Oh, because it's, okay, so now what's the magnitude of 5 minus 8? You follow? I'm looking at absolute value signs. What's the magnitude of 5 minus 8? Or what's the absolute value of 5 minus 8? Well, what's 5 minus 8?
-3.
That's -3. What's the absolute value of -3?
3.
3. The magnitude without regard to direction. You follow the concept? And whatever words you need to put down on the paper that make sense in your own head, write some words down. I mean, you've heard what I said. You've heard the way I explain it. Read page 351 and 352, and then find some words in your head that help you make sense out of what these little bars mean. And it doesn't mean go to jail. Number 8 says the absolute value of negative 2, which is what? 2. Minus the absolute value of negative 3. What's the absolute value of negative 3? 3. What's the magnitude of this one? 2. Minus the magnitude of this one? 3. That would be negative 1. Everybody follow that? It's kind of like the simplifying process. You simplify the absolute value before you do the other stuff. Well, let's look at number 10. Looks like the same kind. No, it isn't. No, because see, what's the magnitude of 3? 3. But what's out in front of it? A negative. Do you see that? So all of a sudden, what they just said here, what this really says is the negative magnitude of 3. Or negative the absolute value of 3. So I do the absolute value of 3 is 3, then put a negative in front of it. Then I'm going to add what? The absolute value of 1 minus 4. What's 1 minus 4? Negative 4. What's the absolute value of negative 4? 4. You follow that? So I put 4 down here. And then I have negative 3 plus 4 equals 1. And by the way, if you turn your homework in with just answers only, you don't get credit for it. And if you say, I think I turned that in, I'll check and say, yeah, I've got it in my pile of papers. That don't get credit because you didn't show your work. You've got to show me how you got the answers. So show your work or you don't get credit for the homework. Number 12. And this is what we're doing here, is showing our homework. Number 12 says, determine which of the following are solutions of the absolute value of x minus 2 is less than 2. And they have 0, 1, and negative 1. So I just put 0 in for x. And what's 0 minus 2? Negative 2. What's the absolute value of negative 2? 2. Is 2 less than 2? No. 2 is not less than 2. So that's false. You see what's going on? Put a 1 in place of x. What's 1 minus 2? Negative 1. What's the absolute value of negative 1? 1. Is 1 less than 2?
Yeah.
Yes. You go, I don't know. I thought I knew, but now that I'm thinking absolute values, I'm not sure if I know anything. So I say, then that's true. C. Put a negative 1 in place of x. What's negative 1 minus 2? Negative 3. What's the absolute value of negative 3?
3.
3. Is 3 less than 2? No, so that's false. You follow what's going on? Negative 2 in place of x. What's negative 2 minus 2? Negative 4. What's the absolute value of negative 4? 4. Is 4 less than 2? No, so that's false. You got it? That's all we're doing. It's not rocket science. It's just absolute value. Although rocket scientists use absolute value, it's not that complicated yet. Number 16. In problems 13 through 18, find the set of integers for each sentence for which each sentence is true. The set of integers. The absolute value of x is less than or equal to 3. So guess what that means? I think that's from page 352 in your book. It means that x is between -3 and 3. You go, what? Okay, watch this. Let's go over here and put the absolute value of x is less than or equal to 3. Let's just pick some numbers. X, since it said integers, let's just pick some integers. 0, 1, 2, 3, 4, 5, 6, and -1, -2, -3, -4, -5, -6, See what I'm doing? I'm just picking a set of integers. Now, if you put 0 in place of x, is the absolute value of 0 less than or equal to 3? Yes, so that's a good one. Is the absolute value of 1 less than or equal to 3? Yes, so that's a good one. Is the absolute value of 2 less than or equal to 3? Yes. Is the absolute value of 3 less than or equal to 3? It's not less than 3, but it's what? Equal to, so that works. What about 4? Is the absolute value of 4 less than or equal to 3? Nope. So you mark it out. What about 5? Gone, and all the rest of them are gone. You follow what's happening? I just make a list of these integers and check them out. Is the absolute value of -1 less than or equal to 3? What's the magnitude of -1? 1. Is that less than or equal to 3? Yes. Does -2 work? Does -3 work? But -4, -5, -6, and the rest of them don't. You follow what's going on? So, instead of doing this every time, you go, you know what's going to happen? When you have the absolute value of a number being less than or equal to something, it's going to be between the negative of that number and the positive of that number. And there it is, right there between. So whenever you see this with an inequality sign, you go, I take all of this and write it like all of this. Every time. And if I do that, then if x is between -3 and 3, inclusive because it equals to, then what did they say to do for this problem, number 16? Find a set of integers. So that means they just want me to put it in the set notation. And there it is. The set whose elements are -3, -2, -1, 0, 1, 2, and 3. You follow me? And you see how I came over here and found those by listing them all and working through it. Number 17. Why are we doing one of yours? I don't know. But let's do it. Number 17 says the absolute value of x is greater than or equal to 1. Now, if it's greater than, then it's x is greater than or equal to 1, or x is less than or equal to -1. Let's go back over here and do this again. Let's go, the absolute value of x is greater than 1. Greater than or equal to 1. So let's go back here. And we're still, are we still talking about integers? Yeah. So we go 0, 1, 2, 3, 4, 5, 6, and so on. And -1, -2, -3, -4, -5, -6, and so on. Now is the absolute value of 0 greater than 1? Nope, so 0 doesn't work. You follow me? I can't use 0. 1? No. Yeah. The absolute value of 1 is equal to 1, so I could use this one. That one works, that one works, that one works, that one works, and all the rest of them after that. You follow what's going on? And going the other direction, -1 works, -2, -3, -4, -5, and so on. So when it says less than, it's going to be between those two numbers. In other words, if I were to draw a picture of this, sometimes a number line helps. Here's 3, here's -3, and it's going to be between those two numbers. If it says greater than, then that means, if I draw a picture of it on a number line, let's go back and do another red number line. Here's 1 and -1, and it's going to be greater than or equal to, so it starts here and goes this direction, or it's going to be less than or equal to and starts there and goes that direction. So see, when it says the absolute value is greater than that number, then it starts at those 2 points and goes out. If it says it's less than that number, then it starts at those 2 points and merges in. So maybe drawing a number line to represent where it says greater than, looks like this, and less than looks like this. And just do something in your notes. I mean, do you understand? You're not going to carry this information around in your head until the exam comes up next Friday, is it? Is that the last day of the semester? So you're going to have to, and plus you're having all this work for all these other classes, just write down some good notes to bring with you when it comes test time. Number 18. The absolute value of x is less than 4. So since it said less than, then I go x is between -4 and 4. And to say it's between -4 and 4, then that means I just go the set whose elements are -3, -2, -1, 0, 1, 2, and 3. Now for 19 through 36, it says graph the solution set of each sentence and write the solution set if possible in interval notation. It doesn't say anything about real numbers. No, it doesn't. Does it? But if you look back at the answer to problem number 23, 6.3 number 23, they've got a graph where they show all the numbers. So whoever wrote the book should have said, since they said use the set of integers here, they should have said use the set of real numbers. But see, the guy who wrote the book, if he was here, he would say, no, I don't have to say that. If it's not the set of real numbers, I tell you to use integers. If I don't tell you what to use, then what do you understand it's supposed to be? And you go, I don't understand anything. That's why I'm taking math class, so I can learn this stuff. Well, it's just understood. You know, don't you get tired of that? It's just understood that if there's an X by itself, there's a 1 in front of it. Well, he would say it's just understood that if they don't designate what set you're looking at real numbers. Well, I'm glad that's understood, but you might want to write yourself a note. If they don't say what set it is, use the set of real numbers to find your answer. So I just wrote down for 19 through 36, since we're doing integers for 13 through 18, for 19 through 36, we're doing real numbers. Okay. And it says graph them and write them in interval notation. Have any of you used interval notation before anywhere in life? I have a brand new concept to give you today. Good. Have any of you done graphing of absolute values before? So we've done some of that. So that won't be new, but it sounds like I'm going to give you one new concept today. So let's go to number 21. Yeah, if it's a new concept, I should work one of your problems for you, just to help you figure it out. The absolute value of x is less than or equal to 4. So I know from page 351 or 352 that I write it like this. X is between -4 and 4. And if I'm going to graph that, then that means I'm going to put a dot at -4 and a dot at 4. And what am I going to do? I'm going to connect the dots. Now, does that make sense to you? That's the graph. Does that picture look like what's said here? That -4 is less than or equal to x is less than or equal to 4? And because it says less than or equal to, I fill in the dot. Now we're going to do it in interval notation. And watch how we do it. Since it said less than or equal to, I just put one of these here and one of these here. Brackets. If it said less than, I would put parentheses. Okay? And then where does it start? At -4. And where does it end up? At +4. And that's called interval notation. Isn't that cute? That's just using brackets or parentheses if it doesn't say or equal to. Where do they explain that to you? On page 353? Yeah. And if they don't do a very good job of it, then just Google interval notation and read to your heart's content. Now, does everyone see how here's the A part of 21 and here's the B part? So for 21, there are two things to do. Graph it. Well, there's actually three things to do. First, you do this. You go from absolute value to this thing, and then you graph it, you draw a picture on a number line, and then you do an interval notation. So let's do number 22. The absolute value of x is greater than 1. So, since it says greater than, I go x is greater than 1, or x is less than -1. So x is greater than 1. I put a circle at 1 and go to the right. Or I put a circle at -1 and go to the left. And the circle means it doesn't equal 1, it just becomes infinitely close to 1 from the negative side. So there's the graph. And what would it be in interval notation? Okay. Now, see, I'm going from -1 to infinity. So I just make my parentheses and put -1 here. And then I have to go to negative infinity. A little figure 8 turned sideways. Or it could be a parentheses with a 1 and a positive infinity. And if, or, back from our set notation stuff, that means it's this or that, which would be the union of those two. And there's your interval notation. That's new stuff, isn't it, for most of you, it looks like. So just write yourself lots of good notes because you're not going to be doing enough practice problems to get it fixed in your head. So you're just going to have to, and there's no reason to try to memorize this information, because you can just put it on notes and bring it with you to the test. Number 24. The absolute value of x minus 2 is less than 1. So that means x minus 2 is between 1 and -1. You go, yeah, but it says x minus 2. That's messing with it. Okay, so watch. Just add 2. But if I add 2 here, I add 2 here, and I add 2 here. So you see, I'm working at 3 places. I'm doing operations in 3 places. And all of a sudden, this becomes this. Is that cool? X is between -1 and 3. So I put a circle at a circle at 1, a circle at 3, and connect the dots. Isn't that cool? That's the graph. Okay. Then I do interval notation. Because it's not equal to, I put a parentheses and another parentheses, and it goes from where? From 1 to 3. Everybody follow the process? When it's not equal to, I use parentheses. When it's equal to, I use brackets. Any questions? What happened?
In the first, go up a little bit more.
On 21?
No, 24.
24?
Yeah, you started with the absolute value of x minus 2.
The absolute value of x minus 2. So I took the x minus 2 and just put it right here.
Right.
And it's between 1 and -1. You follow that process?
Yes. But
So-
you took away the absolute value of bars.
Yeah, by putting this between those two extremes.
Oh.
Okay? You say, why do you do that? Because, remember back up here when I drew my little chart? Here's one, where I said 0, 1, 2, 3, 4, 5, 6, 7, because absolute value is going to let you go in both directions. And it explains that process on page 352 also in the textbook. So then I add 2, add 2, add 2, and I end up with this. Okay? 26. The absolute value is greater than negative 1. When would the absolute value of a number be greater than negative 1? What number could I put in place of x that would have an absolute value that's greater than negative 1? Absolute value is always going to be positive, right? So that means I could put any number in there, any real number. So how do I graph any real number? I make a number line and just color in the whole thing. So how do you do that in interval notation? A parenthesis, another parenthesis, and from negative infinity, comma, positive infinity. There you go. That's kind of dumb, but hey, you know, since he put that problem in the book, we'll work it. Number 28 says the absolute value of x minus 3 is greater than 1. Now, I can actually work this the same way. I just put x minus 3 between 1 and negative 1, but I've got greater than signs. But here's why the book doesn't show you that. Negative 1 is not greater than 1, is it? So I'm just using this technique as a shortcut for doing that OR thing. Because then when I add 3, add 3, add 3, in other words, I've got one procedure that I can use to work all the problems, whether it's greater than or less than. And then what's going to happen is I'm going to have negative 1 is greater than or equal to x, not negative 1. Negative 1 plus 3, that's going to be 2, is greater than or equal to x, is greater than or equal to 4. But see, 2 is not greater than 4 because I'm really saying x is less than or equal to 2 or x is greater than or equal to 4. You follow what's going on? I just left it like this. It's almost like when I see this, I drop the absolute value signs and put this between that number and its opposite. But when I do that, I know I'm going to find the answer. But technically, the book says when you see that, you should write it as or, this or that. But I just want you to see that sometimes you say, hey, I wasn't noticing which direction the sign was going. I'm just taking away the absolute value signs, put this down here, this number and its opposite, and then I work my way through it. And then when they get to the end, then you go, well, if 2 is greater than or equal to x, then x is less than or equal to 2. Or x is greater than or equal to 4, and that's when I would put this and go to the right, or this and go to the left. Everybody follow what's going on? When it's greater than, it's going to be or. When it's less than, it's going to be and. It's between this number and that other number. Oh, and then interval notation. It starts at 2, so I put a bracket there with a 2, and it goes where? Parentheses to negative infinity, and then it starts at 4, comma, and positive infinity, and then it's the union of those two from your old union and intersection stuff. Okay? That's how you write interval notations. Number 30. What's number 30 doing? 3x, the absolute value of 3x is less than 9. So I say, so then I put 3x right here. No, let's go back to blue. 3x right here, and 9, and negative 9. And then divide by 3, divide by 3, divide by 3, and I end up with this thing right here. Now that I have that, I can do my graph. A dot at negative 3, a dot at 3, and fill it in. And then the interval would be a bracket, negative 3, comma, another bracket, up to 3. Because it's or equal to. Okay? Number 36. So I take this, and I have 8 and negative 8. Then I go minus 1, minus 1, minus 1, and I end up with 3x. I end up with all of this right here. Then I divide by 3, divide by 3, divide by 3, and now it gets messy. Because it says negative 3 is greater than x, or x is greater than 8/3, which is the same as 2 2/3. So I go to my number line and put x is, this is also red, x is less than negative 3. So I go to negative 3 and put a circle and go to the left. And then I go to 2 2/3 and put a circle and go to the right. And I just label it under here, 8/3. So you know that that's the number where I made my circle.
Shouldn't it be 2 1/3?
Because 8 minus 1 is 7.
Oh. 2 1/3. Yeah. Yeah, it should be. 2 1/3. There. Thank you. 2 1/3. Or 8/3. So the interval notation, it's a union of parentheses, negative infinity to negative 3, and 2 1/3 to positive infinity. And that's the interval notation. You got it? Now we're ready for some story problems that have to do with using absolute value. And notice it gives you a clue here. In problems 37 to 39, use the absolute value of b minus a is less than or equal to c, where b is the budget, and a is the actual expense, and c is the variance. So for 38, what did they tell me to use here? Use the absolute value of b minus a is less than or equal to c. And for 38, the budget is $800 minus a, actual expense, has to be less than or equal to, for 38, 5% of B. That would be 0.05 of means times 800. What's 0.05 times 800? $40. So I have 800 minus A is less than or equal to 40. Everybody see where I'm getting those numbers? Looks a little messy over here. So we'll just do it over on this side. Then I come down here and I go, okay, I have 800 minus A, and then I put less than or equal to 40. And what goes on the other side? Greater than or equal to negative 40. Remember that? That process, how we get rid of the absolute value sign? So then I have minus 800, and that's negative 840, is less than or equal to negative A, less than or equal to minus 800. What would that be? Negative 760? So what happens now? Divide by a negative 1, divide by a negative 1, divide by a negative 1. And this becomes A is less than or equal to 840. Or A is greater than or equal to, because I have to switch the inequality sign when I divide by a negative number, 760. Everybody see that? So I come down here on a number line and put 760 and 840 and A has to be between those two numbers. Everybody follow that process? What do they want to know for this problem anyway? How much money can it spend if an acceptable variance? So I can spend between $760 and $840 if my budget is $800. If I don't spend $760, next year they'll cut my budget. And if I spend more than $840, they'll reprimand me for going over budget. Number 42. An average male, 5 feet 8 inches tall, should weigh between 152 and 172. So, here's where he should be. Between these two numbers, his weight should be between 152, which means it should be less than or equal to 172, and greater than or equal to 152. If he's below 152, he's below average. If he's over 172, he's above average. So what do they say? If you're below 152, you're too skinny, and if you're over 172, you're obese. No, you're just overweight. I don't know. They keep throwing ugly words at us. I just like to eat too much. That's my problem. Now, here's the tricky part. They want me to write an absolute value equation. Okay, from 152 to 172, how far is that? 20? So right in the middle of those two, what would be halfway between those two? 20 divided by 2 is 10. It's like you're finding the average or the median in the middle of it. So 162 would be the number that's right in the middle of those two. Do you follow what I'm doing? I subtract them to find how far apart they are. Then I say this one plus 10 and this one minus half of that is going to take me right to the middle. So watch what I do. I go, well, now that I found the middle, I go, your weight minus 162 has to be between 10 and negative 10. You go, where did that come from? Here's 20. So half of that from 162 up 10 or down 10. You follow that? So do you see where I'm getting this little sentence right here from all that information they gave me? Now, once I have this, is it easy to go to this? Just take the absolute value. Just go out here and write the absolute value of W minus 162 is less than or equal to 10. See that? Because that absolute value is what lets you go 10 or negative 10. So I can have this weight minus 162 minus the average can either be less than 10 or greater than negative 10. That might be, that 10 and negative 10 might be the part that's messing with you a little bit. But it's basically, if the range is from the low to the high is 20, then half of that is going to be the number that's going to go out here outside of my absolute value sign. And then if I simplify that, if I add 162 to everything, and add 162 here, then I get 152 is less than or equal to W is less than or equal to 172. And you say, well, that's what I started with. Yeah, so in a sense what happened is I answered B first by just going from the information they gave me to this first little setup, and then I went from there to the absolute value. 44. A machinist has to build a 1-inch long bushing. So here's the bushing that I'm building, and it's going to be 1 inch long, but there's some variance. So I'm going to take the length of the bushing minus 1. You follow that? With no more than 1% error in length. So the absolute value of that bushing minus 1 has to be less than or equal to 1% is 0.01. And since they're using L for length, I just came in and said, okay, so what they're saying is the absolute value of L minus 1 is less than or equal to 0.01. Then that means that I have L minus 1 is between this and this. So I add 1 to all three of them and I get this. And now see, now watch how this makes sense. You're working in a machine shop. You're supposed to be making 1-inch bushings, and your tolerance is 1%. That means when the bushings that I'm making are finished, the guy who's checking in quality control says it can either be 1/100th of an inch over 1 inch or 1/100th of an inch under 1 inch. But if it's any more than that, we have to throw it away and make a new one. And if we keep throwing away bushings because you're making them with too much sloppiness in it, you're going to get fired and we're going to hire a new man to run the machine. You go, I don't think I want that job. Well, then don't take it in the first place. Go find another one. Say, yeah, but it pays well. Yeah, it does, because of what they expect of you. So number 44 says, write an absolute value equation. We did that here. And then B, simplify the inequality. We did that here. You follow what's going on? All of these problems have you using this absolute value thing for a tolerance that's out there. And stop when you get to 45. So it looks like 41, the average female is just like 42. You say, well, what do you do with the height? Nothing. You don't even use that in working the problem. And then for 43, a plumber wants to cut a 12-inch foot length of pipe. So that's going to be just like this machinist. It's going to be the length of pipe minus 12. Has to be less than or equal to 0.02. But it's not 0.02 times 1, it's 0.02 times 12. You see that? Because it's 12 inches long, so you have 0.02 times 12 as the tolerance. And then for number 45, you just put the score S minus 505 has to be plus or minus 4, less than or equal to 4 is your margin of error. Okay? Have a nice day. If you need some more help from 6.1 or 6.2, I will be here to answer questions until my class starts at 9:30.